Alright, Mr. Walber here for section 9.3, surface area cylinders. As it says here, the surface area is the sum of the two bases and the lateral surface. There is a formula if you want to use it. This one, comparison to the last two sections, might be something at least I use a little more than the other last two sections. 2 pi r squared would be the area of the two circles of a cylinder, and the area of a curved surface, which we'll get into, is 2 pi rh. First of all, if you look at a cylinder, think of a soup can. You have a top circle and you have a bottom circle. So that's why pi r squared, the area of a circle, is pi r squared. We're going to multiply that by 2 because you have obviously a top and a bottom. When you open it up into a net, obviously there your two circles there, a top and a bottom. The area of a curved circle is kind of interesting. If you unwrap the paper around a soup can, believe it or not, it would open all the way up into a rectangle that looks just like that. The strange, interesting thing is the height of the cylinder is obviously the 6. This circle opened up is this length right here. Again, this circle opened up is that length right here. So if you follow that all the way around, you got to use your imagination of a soup can. If you follow that all the way around the circle, it would be this entire length of that rectangle right there. But anyway, this is the formula that we will be using, so you might want to write that down. First practice problem. Let's go about doing this. As we said, 2 pi r squared plus 2 pi rh. Let's start with 2 pi r squared. My radius is 4, so I'm going to multiply 2 times pi times 4 squared. 4 squared, 4 times 4 is 16, so I'm going to be 2 pi times 16. When I do that, I'm going to get 100.48. Then I'm going to add that to 2 times pi times r is 4 and h is 3. I'm going to go ahead and multiply that. Of course, by the way, I'm kind of jumping this. At this point, you should know that pi, we are going to go ahead and just use 3.14 for that. So when I go about doing that, I'm going to multiply that together, and I'm going to get 75.36. Go ahead and add these two together, and I'm going to get 175.84, and I'm going to go ahead and I'm going to label, this is millimeters, so I'm going to label that millimeters squared because it is an area. So that's a great example problem of how we would go ahead and find the area of, the surface area, of a cylinder. Speaking of soup cans, well, I guess this isn't soup, but it's a can of sweet peas, which I'm sure is everybody's favorite. It says how much paper is used for the label on the can of peas. Now, interesting enough, you got to think about it. We don't need to use the first part of the formula, 2 pi r squared, because we do not put paper on the top or the bottom of that, so that is not needed. All we need is the 2 pi rh. So when I go about doing that, I'm going to multiply 2 times pi, again 3.14, times the radius of 1 times the height of 2. When I go ahead and I multiply those up, I'm going to get 12.56. It's still an area, it's just the area of that paper, inches squared. That's it. Because that was so much fun, and I really dislike tomatoes, let's go ahead and talk about another one. How much paper is used for this label on the can of tomatoes? Again, we don't need the first part of the formula. All we need is 2 pi rh. I'm going to multiply 2 times pi, times the radius of 2 times the height of 5.5. When I go ahead and multiply that up, I get 69.08. And again, I need a label, inches squared. So I hope you're following along on that second part. Obviously, if we needed to find the circle, we would go ahead and we'd use the part of the formula, which is 2 pi r squared, to do the top and the bottom. But obviously, in this case, we don't need that because we're only doing the side. Couple practice problems, pretty straightforward. Just go ahead and use the formula. I hope you wrote it down. Find the area of the surface area of these two cylinders. It does say round to the nearest tenth. I'm a bigger fan of hundredths, so let's stick to that, please. Sorry, I'm gonna change that right now. Please round the nearest hundredths, and if needed, obviously. And I will see you tomorrow. Have a good night.